Imagine the audacity of a species that dares to touch an asteroid, a celestial body millions of miles away from Earth. This bold vision became a reality when, in the autumnal month of September 2016, the OSIRIS-REx spacecraft was launched from the storied grounds of Cape Canaveral, Florida. The anticipation was palpable, a tangible force resonating through the crowd of onlookers. The rocket engines ignited, a brilliant blaze of orange and white, punching a hole in the sky as it propelled OSIRIS-REx towards the inky blackness of space. The launch was a spectacle, a testament to human ingenuity and our relentless pursuit of knowledge. But the journey was just beginning. The spacecraft, named after the Egyptian god of the afterlife, had embarked on a 2-year odyssey around the sun. This wasn't a leisurely cruise but a calculated maneuver, a gravitational slingshot designed to gain the speed necessary to pursue its quarry, the asteroid Bennu. OSIRIS-REx, like a cosmic voyager, sailed through the void of space, powered by the sun's rays and guided by the hands of its earthbound pilots. It traversed the solar system, its path illuminated by the distant stars and the ever-present sun. It was a voyage of discovery, not just for the spacecraft but for us, its creators. We learned about the resilience of our technology, the vastness of our universe, and the audacity of our dreams. But let us not forget the purpose of this monumental journey. OSIRIS-REx was not just a spacecraft, it was a time capsule, a carrier of human ambition aimed at an asteroid millions of miles away. Its mission? To touch the surface of Bennu, to gather precious samples, and to bring them back home to Earth. With the successful launch and journey, OSIRIS-REx was now on course to meet Bennu, the target asteroid. The stage was set for a rendezvous that would not only challenge our understanding of the universe, but also redefine the boundaries of human achievement. 2 years into its journey, OSIRIS-REx finally encountered Bennu. This was not just any asteroid. Bennu was a relic from the early solar system, holding secrets about the origins of life and our universe. OSIRIS-REx's first sight of Bennu was a moment of awe and intrigue. The spacecraft's initial survey revealed an asteroid that was both fascinating and formidable. Bennu was not a smooth, lifeless rock as previously imagined, but a rugged, boulder-strewn world, an active and dynamic place with an environment far more complex than anticipated. The most unexpected discovery was Bennu's active surface. The asteroid was ejecting particles into space, a phenomenon never before seen on an asteroid. These particle ejections were a surprise, adding a new layer of complexity to the mission. It posed a potential risk to the spacecraft, which was designed to operate in a predictable and quiet environment, not a chaotic and active one. But the surprises didn't stop there. The team needed to find an area on Bennu suitable for sample collection, a flat, boulder-free area about 50 yards wide. But Bennu was full of boulders. The team had to change their strategy and look for something much smaller, eventually settling on a site less than 10 yards in diameter. They named it Nightingale after the bird known for its beautiful and powerful song, a fitting name for a site that held so much promise. Nightingale was nested within a crater in Bennu's northern hemisphere, a site rich in fine-grained material, just what the mission needed. But it was surrounded by large boulders, making it a challenging target. The team had to navigate OSIRIS-REx to an area smaller than a few parking spaces on Earth, millions of miles away. Despite the challenges, the team was determined. The stage was set for OSIRIS-REx to make its daring attempt. This was not just about collecting a sample, it was about pushing the boundaries of human knowledge and capability, about venturing into the unknown, about the spirit of exploration that drives us to reach for the stars. The touch-and-go, or tag event, was the crucial moment of the mission. Imagine this, a spacecraft, millions of miles away from Earth, descending towards a relatively small asteroid, with the task of collecting samples from its surface. Sounds like a scene from a sci-fi movie, doesn't it? Well, this was the reality for the OSIRIS-REx mission in October 2020. The touch-and-go maneuver, fondly known as TAG, was a delicate and intricate process. It was akin to a cosmic ballet, with every movement meticulously planned and executed. The stage was set, the audience back on Earth held their breath, and the spacecraft began its descent towards Bennu. But how does one go about collecting samples from an asteroid's surface? It's not like there's a handy scoop or shovel attached to the spacecraft. That's where the genius of the TAG system comes into play. OSIRIS-REx was equipped with a device called the Touch-and-Go Sample Acquisition Mechanism, or TAG-SAM. Think of TAG-SAM as a pogo stick with a reverse vacuum cleaner on the end. As the spacecraft gently touched the asteroid's surface, TAG-SAM fired a burst of nitrogen gas. This gas billowed against the surface, stirring up rocks and dust particles. These particles were then caught by TAG-SAM's collection head, a bit like how a butterfly net catches butterflies. This all sounds straightforward, but remember, this was happening millions of miles away, on an asteroid barely half a mile wide, moving at speeds of thousands of miles per hour. The precision and control required for this operation were immense. There was no room for error. One wrong move, and the mission could have been jeopardized. The TAG event was a resounding success. After descending to the asteroid, OSIRIS-REx made brief contact with Bennu's surface, fired its nitrogen gas, and managed to collect a substantial amount of material. The spacecraft then ascended back into orbit around Bennu, carrying with it precious cargo that could hold the answers to some of our most pressing questions about the universe. It was a moment of triumph, a testament to human ingenuity and the relentless pursuit of knowledge. The successful execution of the TAG event marked a significant milestone not just for the OSIRIS-REx mission, but for space exploration as a whole. It was a demonstration of what we can achieve when we push the boundaries of what is possible. This was a mission of firsts. The first US mission to carry samples from an asteroid back to Earth. The largest sample returned from space since the Apollo era. And it all hinged on the success of the touch-and-go sample collection. Against all odds, OSIRIS-REx had successfully touched an asteroid and collected a sample. With the precious cargo secured, OSIRIS-REx began its journey back to Earth. A journey that would take a little over 2.5 years, with an expected touchdown in late 2023. A long wait, you might think, but worth every second for the wealth of knowledge this mission promises to deliver. This isn't just any mission, it's one that could potentially unlock mysteries about the very origins of life. How so? Well, asteroids like Bennu are believed to be remnants from the early solar system, virtually unchanged for billions of years. They are in essence cosmic time capsules. The samples collected by OSIRIS-REx could provide us with a snapshot of the early solar system, offering insights into the materials and conditions that contributed to the birth of life as we know it. But the significance of this mission extends beyond our quest to understand life's origins. It also deepens our understanding of asteroids themselves. These celestial bodies are not just intriguing scientific subjects, they are also potential threats. Asteroids have collided with Earth in the past, causing significant damage, and they will undoubtedly do so again in the future. A detailed study of Bennu could help us better predict the behavior of other asteroids and potentially develop strategies to mitigate the risk of a catastrophic impact. Moreover, asteroids could play a pivotal role in the future of space exploration. They are rich in resources, including water and metals, which could be used to support long-duration space missions and even the colonization of other planets. By studying Bennu, we're not only learning more about our past, but also preparing for our future in space. The return of OSIRIS-REx is a momentous occasion, not just for the scientific community but for all of humanity. It's a testament to our insatiable curiosity, our willingness to push the boundaries of what's possible, and our ability to work together to achieve a common goal. It's a reminder that we are part of something much larger than ourselves, a vast and awe-inspiring universe that still holds many secrets for us to discover. This mission isn't just about collecting samples from an asteroid, it's about daring to dream big, to reach out into the unknown, and to touch the stars. It's about the journey of discovery, the thrill of exploration, and the joy of learning. It's about understanding our place in the universe and striving to make it a little bit bigger. As we eagerly await the return of OSIRIS-REx, we celebrate this incredible feat of human innovation and curiosity. We dared to touch an asteroid, and in doing so we have opened a new chapter in our quest to understand the universe.